Introduction. The data link layer delivers the packets between two systems on the same network, but it is required that the data must be shared between multiple networks crossing many intermediate routers along the way. The network layer has the ability to deliver the individual packets from source to the destination host, possibly across multiple networks. To get this job done, the network layer must know completely about all the routers and links on the network. And it chooses appropriate path to move data between source and destination. To move data between source and destination across multiple networks, we must need a kind of addressing system that helps in identifying source and destination. So, let us jump into the network layer, learning about the addressing and its protocols. Logical addressing. The data that has been sent from a source computer may pass through many LANs and WANs to reach the destination computer somewhere else in the world. To achieve this, we need a global addressing system called logical addressing or IP addressing. The network layer adds a header to the packet coming from the upper layer. This header contains the IP addresses of the sender and receiver. These addresses are referred to as IPv4, IP version 4 addresses, or simply IP addresses. And the address is 32 bits in length. This gives us a maximum of 2 to the power of 32 addresses. The increase in the use of electronic devices has led to a new version of IP addresses, called IPv6 addressing, and it has a length of 128 bits that give much greater flexibility in address allocation. So, we first discuss the IPv4 addressing, and then move on to the IPv6 addressing. IPv4 is a 32-bit long address. It universally defines the connection of a device, for example, a computer or a router, to the Internet. IPv4 addresses are unique. That means, each address defines one and only one connection to the Internet. Two devices on the Internet can never have the same address at the same time. Simply put, if a device operating at the network layer has M connections to the Internet, it needs to have M addresses. That means, when you are connecting your mobile device through Wi-Fi from your home router, you have one IP address, and when you connect your mobile device to your cell network or mobile data, you have another IP address. It is important to note that, an IP address does not actually refer to a host. It actually refers to a network interface, so if a host is on two networks, it must have two IP addresses. The total number of addresses used by the protocol is 2 to the power of 32 or 4,294,967,296, because it uses 32-bit long address. This is called the address space. Theoretically, if there were no restrictions, more than 4 billion devices could be connected to the Internet. The address space is 2 to the power of n, because each bit can have two different values, 0 or 1, and n bits can have 2 power n values. We can show an IPv4 address in two notations: binary notation and dotted decimal notation. Binary notation. IPv4 address is written as 32-bit with 4 octets each having 8 bits. The following is an example of an IPv4 address in binary notation. Dotted decimal notation. To make the IPv4 address easier to read, Internet addresses are usually written in decimal form with a decimal point dot separating the bytes. The following is the dotted decimal notation of the above address. Note that because each byte or octet is 8 bits, each number in dotted decimal notation is a value ranging from 0 to 255. Some rules must be followed while writing the IPv4 addresses. Those are: there must be no leading zero like this. There can be no more than 4 numbers in an IPv4 address. Each number needs to be less than or equal to 255, 310 is outside this range. A mixture of binary notation and dotted decimal notation is not allowed.